Hi, my name is Sergey Vlasov. I'm from Kryptonite company, and I will talk about the Reliance Nitro file system working with FlashFX Tera memory manager. High performance managers for working with flash memory with the Reliant file systems are used widely in the current industry products. They ensure the reliability and security of your data, of critical data. FlashFX Reliance Nitro that works with the non-processed memory manager was introduced by a private company, Data Light Inc. The developer of this system and the owner of the company was the lead engineer for Boeing. In 2019, this company has become a daughter of a Finnish software developer, Tuxera. The features of Reliance Nitro come from the idea that it has to work in a situation when you have high resilience system working with potential power losses. The unprocessed flash memory dispatcher was developed to integrate with a lot of different integral memory chips, including both sequential and parallel memory, NAND and others. Reliance Nitro can work with any 32 or 64-bit systems, with any file systems. There are ported versions for Linux, Xworks, Android, and Windows CE. Usually, the developers choose FlashFX Tera management dispatcher together with Reliance Nitro. The Reliance Nitro file system with the manager is used in space, in video modules, including the International Space Station, in some Mazda automobiles, in video registers, navigation, and other multifunctional devices, like printers and high-performance data storage systems. There's a number of ways you can use to access data in Reliance Nitro format using FlashFX Tera. Those methods are software-based and hardware-based. The software-based methods give you access to the interface, to find the commands, maybe enter debugging mode, passing some special commands, switching jumpers on the motherboard. Also, you need to intercept the interface, whether software-wise or hardware-wise. together with all the timings that are sent through the protocol. So that you could simultaneously analyze the exchange protocol, disassembling the software, managing the device or the device driver, to ensure the exchange protocol is valid and you can read the dump from the device. The software method is only viable when the controller, the device, SoC or the processor, encrypts the data before writing it in memory. Then the software method will not work because the data will be encrypted. But if the device has unauthorized access protection, both software and power loss monitors that allow to find logical analyzers being connected. So it's easier on the one hand because you don't need to do it based on software, but the software method is easier. Thus, if we understand that the controller does not encrypt the data, then you can remove it from the hardware and you can analyze it further on. The hardware methods differ depending on the current state of the device and how you do the research. You can use popular readers, programmers, and especially I would like to highlight the PC 3000 mobile, which allows you to work with different memory modes, including phones and industry solutions. Moreover, this product has a very powerful data extractor. Enables you to restore the data streams that would not be otherwise available, especially by forensic criminalists, forensic experts. They usually spend weeks on doing such things. If the memory has a non-standard technical connections, then we have specific adapters. And it's important that PC 3000 Flash has a spider board. It helps you use the needles to connect to the memory chip, define the voltage, the core voltage, and automatically define the interface. So the program itself defines which interface is being used. In most of the cases it works. After you read the memory dump from the device, you need to check the correct the bit mistakes, and as the technologies, memory technologies differ, there are different types, SLC, MLC corrections, when the cell can store more than one state. QLC stores 4 bits in one cell. And this leads to increased probability of bit mistakes. So the developers of the translators or dispatchers use the correction codes. FlashFX Tera has a number of types for code correction. Hemming codes, that can help solve 1 bit for 512 bytes of data. And as different devices use error correction differently, sometimes it's just the processor itself. And in some cases, the loader is placed in a number of places, and it can read it from different places, checking whether the checksum is okay. Thus, the error correction is delegated to FlashFX. The second type is the ability to fix 4 bits for 512 bytes. Post-Chaudhary is used for all types of memory, the core and the file system. Uses the code to correct the mistake. So we can read from the memory dump and calculate the ECC correction codes. It differs slightly from popular standards that are well known to data labs and data restoration labs. Each of them have 4 blocks of 512 bytes. The correction code is calculated and is put into the last page of memory. And while the first ECC block plus 6 bytes address is the code itself, and then within 6 bytes is an address that points to the logical memory. So the counter is highlighted red on the right. Yellow are the ECC codes. To analyze the dump after the bit correction, you create a copy without the ECC blocks and use data extractors either from software packs or ordinary hex editors, where you look for the original addresses of segments to then open it using just an ordinary file manager. You can even use 7-zip archiver for this. 7-zip can usually open even a squash device bit by bit, and so that you could get a driver from there for FlashFX. And the driver would contain all the algorithms. You also have Linux binwalk utility that help you find the addresses for all the signatures and files and recursive file extraction. If the data is intact. So FlashFX binwalk did not work. It showed us the addresses, but I had to cut manually the data by sectors, and then I'll work with 7-zip. You also have entropy analysis. It helps you get the spread of bytes in the image to understand whether there's any encryption or compression or obfuscation. They look quite similar. The graph shows that zeros are FFs, and at max these high levels in the middle are a squash file system. So this is an archived file system, that's why the entropy is so high. So after we know the addresses, we use 7-zip to get the drivers out, and of course the files and drivers can be on different places. Then you can disassemble the FlashFX driver, understand how it works, call the functions mentioned, and then it passes the control to the translator itself. You then need to project from physical memory into logical memory. You take 64 pages of memory, call it a unit, add a header with all the params for the logical page and the structure of the file system. You can define the header for FlashFX. There's a unique sequence of bytes and the parameters that carry the logical sense. So we pass the check, and this is IDA pseudocode. You see that the header is being checked, and it's great that the developers did not obfuscate the header, so we see all the functions. There's also a manager for bad blocks that redefines the memory pages in case of malfunction. And then after we build the logical image, we can just download from Honeywell the driver to run it. And as we analyze the dump, we find the containers, FlashPack containers, including the encrypted ones, protected ones. FlashPack does not have a lot about it on the internet, but we found out how it works. There's NAND memory, there's a controller carrying the master key that's uploaded to RAM and can be extracted by the logical analyzer to open the container. There's also logical analyzers that we connect with the polymer contacts, and we can also remove the case from the chip using plasma chemical methods. Then we actually solder the contacts to the chip, even if the controller did not allow us to access those areas. So we've defined both software and hardware methods to access. They all have their pros and cons for security analysis of specific hardware. Thank you for your attention, and we'll be happy to answer questions.